Mike, I apologize I didn't get your official bio, but I pulled from your website profile. So Mike Caggiano has several years experience as a community wildfire mitigation specialist and wildland firefighter in New Mexico. He now works at Colorado State University researching the wildland-urban interface, pursuing a PhD, and working with local forestry collaboratives. He is interested in high-resolution mapping and the spatial dynamics of the wildland-urban interface, and he's involved with several fire-adapted community efforts in New Mexico and Colorado promoting the use of prescribed fire. So thanks so much for joining us, Mike, and I'll turn it over to you.
Thank you for having me. So I'm just going to go over real quickly the basic concepts of that blog I'd written earlier. I'm going to assume everyone has read that, so I won't go into too much depth, but I'll just go over it real quick so we're all kind of on the same page. If you could move to the next slide, please, Liz. Thank you. So what we're going to talk about are PODs, and PODs stand for Potential Wildfire Operational Delineations. And you can think of these as boxes we want to keep the fire in using roads or old fire scars, drainages, or ridge lines. And I'll talk about that a little more here on the next slide. But the reason we do this, like Brenda had mentioned, is when the fire starts and when a hillside or community is on fire, it's too late to coordinate what those objectives are or what that response tends to look like. So the concept behind this spatial fire planning is to do a lot of that before the fire starts. If you do that before the fire starts, if you know where you want to put your containment lines, if you know what the objectives are in specific areas, you're going to be ahead of the game. And if you know what the objectives are and where your containment lines are, you might even be able to figure out what sort of resources you're going to need on that fire. And like was mentioned earlier, these fires obviously don't know boundaries. They're going to go where they want, irrespective of who owns the land or who manages that land. So the general idea behind the spatial fire planning is it facilitates that aggressive suppression when there's a need for that during extreme conditions, and hopefully it facilitates smart decision making and maybe managing for resource objectives when the conditions are more moderate, and reintroducing fire is actually going to cause some ecological benefit. If you can move to the next slide, please. Okay, so what we did here is we sat down with a bunch of local firefighters from both the U.S. Forest Service, the state, local counties, and fire protection districts, and we asked these local experts to identify control lines with the highest likelihood of success. The figure on the left is an example of one pod, and we did that across the entire landscape. I think it's almost 1 million acres. And so we identified those roads and rivers and ridgelines, old fire scars, and fuel type transitions that we think would make the best control lines. And then using those control lines, we chunked the landscape up into these pods, or you can think of them as large contiguous areas or polygons or burn blocks. Just for context, these are scale independent, so they can exist at a whole range of scales, but most of what we're seeing on this landscape here, and the map you're looking at now is from northern Colorado, is we're seeing pods range from several hundred to several thousand acres. If you could move to the next slide, please. Great. So this is part of the process that we went through. We had these workshops where we invited resource specialists and line officers and fire staff, both in the U.S. Forest Service and the adjoining jurisdictions, and we all poured over these maps, and we identified which control lines we thought made the most sense, and this is really playing off cumulative several hundred years of fire experience between all the experts in the room, and so we felt pretty comfortable with that as our starting point. Next slide, please. And then what we did is, what this concept does is it leverages that local expertise, and it adds some advanced spatial analysis, which can act to help validate where we selected those control lines. So some of these products that you're seeing here, the suppression difficulty index and the potential control line locations, are products being developed by Rocky Mountain Research Station. And what they do is they model probabilistic fire behavior and a whole host of other variables that speak to the access and the suppression difficulty and the likelihood those lines would hold in the event of a wildfire. And that way we can chunk the landscape up and we have more confidence. So we're relying on both that local expertise and advanced spatial analytics and fire modeling. That helps us know we've picked these control lines in the right spot, and it gives us some confidence that they're going to hold, and where areas on the landscape where it would be difficult to suppress a fire, those are not good areas for potential control lines, and so we try and work around them where opportunities exist. Next slide, please. One of the central components of this effort is incorporating risk assessments and response functions. So not only are we looking at where can we control the fire and where is it difficult to suppress fires, but we're also looking at what those values are in each pod. And those values can be something along the lines of the urban interface and homes that are at risk, or they can be something like wildlife habitat or even a ponderosa pine ecosystem. And that figure on the left there shows the response function. So what we would estimate is that, for instance, a ponderosa pine forest would respond well to a low-intensity fire, well to a moderate intensity fire, and then as that intensity increases, as that flame length increases, it would we would have a more negative net value change. We take that net value change on a per pixel basis. We multiply that by the probability of fire occurring at a range of different intensities, and that creates what you see on the right, which is the net value change map that shows how various resources would respond to different intensities of fire. Next slide, please. So here's where we're starting to depart a little bit from the blog post earlier. This is starting to get into some of the next steps, where we're going with this iterative process. One of the products that we wanted to create, or that we thought would be helpful, is what we're calling the pod atlas. So in each pod, we can summarize all those assets and values and hazards. So what you're seeing on the right is a simple worksheet where we identify what the values at risk are, so how many homes are in a pod. We look at the local ecology, and we can see the dominant forest types, or the disturbance regime, so how far departed this area is from historical conditions, and the effects of the recent bark beetle infestation. Those are going to play out in terms of driving fire behavior until we start to estimate what are likely scenarios of fire behavior this specific area is likely to experience under different conditions. And this can act as a decision support tool to help set objectives in a fire. Next slide, please. We have seen some measured success with this. There was one small fire we experienced here outside Rocky Mountain National Park on the Arapahoe Roosevelt Forest. And this is the first fire in about 20 or 30 years where the forest took a hands-off approach. Well, that cloud does look ominous. This was actually a pretty small fire, I think about 1,300 acres. It's in a high alpine area. And what you're seeing there are some quotes I pulled out of a press release where it speaks to the concepts that we're trying to implement. So the forest took a hands-off approach because there was very little risk of this fire affecting any resources. It wouldn't have been safe to put firefighters in harm's way, and they are kind of backing off to those pre-established control lines. So while the lines themselves were inside of a much larger pod, it speaks to the concept as slowly being embraced here. And I'm hopeful that this is indicative of a slow shift in culture. Next slide, please. Speaking of that slow shift, what we're having to do is marry this effort with these legacy fire plans. So the 20 or 30-year-old fire management plan here in the forest has three main types of response. You see the direct control, perimeter control, and prescription control there. So what we're starting to do here is work through and develop what those predetermined burning conditions are at the pod scale, so that when something starts, it helps align what those objectives are. Next slide, please. This is still very preliminary right here, but we're trying to identify a simple metric that could be used to help us identify when fires might be good candidates for management. And so the idea we're currently going with, and we haven't made too much progress on this yet, but is having a control threshold and an effects threshold, whereby if a fire starts under a certain threshold, we're fairly confident we can keep the fire in the box, and if the fire starts under a separate threshold, we're fairly confident that the ecological effects would be beneficial. And this goes back to that risk assessment slide I had mentioned earlier, which helps us understand how different resources would respond to a wildfire. Next slide, please. So the other cool thing that we're doing now is starting to coordinate objectives and use this as a communication tool, helping agencies align objectives beforehand, helping plan where control lines need to be, and doing some mitigation work around those pre-existing control lines so they can facilitate the management of a fire. You'll see that red box on the left figure there. That hole in the middle of the national forest is Rocky Mountain National Park, and that corresponds to large purple blob on the middle figure. And so We are starting to have these conversations that look at risk transmission and that what happens if a fire moves from Rocky Mountain National Park to the adjacent urban interface. What happens if it starts in the park and moves to national forest up in the wilderness, and what happens if it starts on national forest and then moves to Rocky Mountain National Park. You can look at the table down below where we highlighted a few example fires, and we can show, we can model fire, and we can show how that risk is transmitted, and we can show the number of structures affected, or the effect that these different fire scenarios might have on other resources. Next slide, please. And along those lines of using this as a communication tool, we're working with water utilities on the Colorado Front Range, which cumulatively provide drinking water for about 2 or 3 million people, plus a whole bunch of agriculture. And we're using this pod planning framework as a way to identify potential treatment areas where we can most effectively safeguard the drinking water sources. And so these are all conversations that are happening now. I've noted that a lot of the agency folk and a lot of the cooperators are really embracing the pod concept because it's planning at an operational scale in ways that watershed level planning are too large in many cases, and then the per pixel raster analysis, that's a hallmark of GIS and spatial planning these days. That occurs at too small of a scale. So since the pods occur at an operational scale, people are finding it really easy to wrap their head around. And since fire is a dominant disturbance on this landscape, as it is on many others, the scale at which we manage for that and the scale at which we plan for that needs to be commensurate with the scale of the disturbance. Next slide, please. And that pretty much wraps up my presentation. There's my email. If anyone has any follow-up questions, you're more than happy to, you're more than welcome to get a hold of me. And then I did want to acknowledge that a lot of the slides, concepts, data, and figures in my presentation, they came from Matt Thompson, Chris O'Connor, Dave Kalkin, all at the research station, and then Ben Gannon, my colleague here at the Colorado Forest Restoration Institute. And those are all great resources as well.